All right, let's look at the first problem in terms of applications of using these ratios and proportions and fractions and decimals and so on and so forth. This will kind of summarize now the first 5 tapes in terms of type of problems that you see on task test dealing with word problems or stated problems, however way you want to talk about them. All right, let's look at the first one. The electrician works 2 2/3 hours of overtime on Monday, 1 1/4 hour. Well, wait a minute. What you need to understand is you're going to see fractions written like this quite often on the computer and in the present day world in a lot of printouts. So we need to get used to reading it this way rather than having the fractions where the 2 is directly over the 3. So let's go back and read the problem again. Electrician works 2 2/3 hours of overtime on Monday, 1 1/4 hour on Wednesday, 1 1/3 hour on Friday, 6 3/4 hours on Saturday. Find the total number of hours of overtime work during the week. Now when you read the problem, you should read it 2 or 3 times. Don't read the problem and just start writing down numbers and slapping down numbers and trying to decide where you're going to add, subtract, multiply, or divide. Read the problem and then think as if you are that particular person. Now what would you want to do if you work 2 2/3 hours on overtime on Monday and 1 1/4 hour on Wednesday and so on? Well, you'd add those up. So that's what we'll do then. So then we will take 2 2/3 and then we're going to add 1 1/4. And we're going to add 1 1/3, and we're going to add 6 3/4. All right, one way of adding these is to take the fractions and make them all into the same denominator. So common denominator is 12, so if I multiply by 4, I will have 8 twelfths. Here I will have 3 twelfths. Here I will have 4 twelfths, and here I will have 9 twelfths. Now adding 6, 7, 8, 10, and adding the twelfths, I have 9 and 4 is 13, and 3 is 16, and 8 is 24 twelfths, which is 2. So I have 10, the whole numbers, and then 2 from adding the fractions, so the answer is 12 hours. All right, another way of working problems like this would have been to add the 2 and the 1 and the 1 and the 6. That gives you 10. And then add the fractions. You have 1/3 and a 2/3, so that's 1. And you have a 1/4 and a 3/4, which is 1. In other words, reasoning or mechanical work, whatever it takes, is what we're trying to teach you in the first 5 tapes is how to add fractions. What this problem is trying to teach you how to read a sentence and know whether you add, subtract, multiply, or divide. Now let's look at the second example. It says a board 8 2/3 feet long is cut from a board 12 feet long. What is the length of the board remaining? What's the length of the part that's left over? Well, that means if I have a 12-foot board and I'm going to cut this away, then I'm going to take that away from it. What I have left, then that's subtraction. So I'd have 12, and I would have 8 2/3. Subtracting that. Okay, a way of doing that is to change this to 11 and come over here with 3/3. Make this 8 2/3. And subtracting now, we get 3 1/3. And learn to put down the words that go with it. 3 1/3 feet. All right, another example is the next one. Says a restaurant cook earns $36 for working 1 shift. what does the cook earn for working 3/4 of a shift? 3/4 of. Okay, that's this times that. The word of usually means 3/4, as you've learned in the other tapes. I'm sorry, the word of means multiplication. So it's 3/4 times the shift. Now, what is the shift? The shift is $36. So multiplying this, well, we can do this. Consider this is over 1. We will divide 4 into that. Go 9 times. 3 times 9 is $27. 3/4 of a shift. 3/4 times whatever the shift is, which happens to be $36. All right, let's look at the next example. It says a person can walk 3 1/3 miles in 1 hour. How many miles can the person walk in 2 1/2 hours? Well, that'll do some thinking. Now, that says that 3 1/3 miles you can walk in 1 hour. So what can you walk in 2 hours? Well, 2 times that. What can you walk in 3 hours? 3 times that. So the problem says how many miles can the person walk in 2 1/2 hours? So that means times. So we'd multiply 2 1/2. All right, now to multiply fractions, we change these to improper fractions. Okay, we do that, but 3 times 3 is 9, plus 1 is 10. 2 times 2 is 4, plus 1 is 5. Now, multiply that out, that would be 50 over 6, which we can reduce. Divide 2 into this, divide 2 into this, and we get 25/3. Or, which can be written as 8 1/3. What? Miles. 8 1/3 miles. Okay. We could have come back up here to start with and divided 2 into the 2 is 1 time, 2 into the 10 is 5. We would have had 5 times 5, which is 25. 3 times 1 is 3. So you can get the same answer. All right. Let's look at the next page and the examples there. Okay, it says, Jane estimates that she spends 1/3 of each paycheck on rent and 1/4 of each paycheck on food. And notice the 1/3 of, that usually means what? Multiplication. Okay, on what? Paycheck. So this 1/3 will probably be times, right here, paycheck. But let's read the problem completely now. Jane estimates she spends 1/3 of each paycheck on rent, 1/4 of each paycheck on food. If her paycheck is $300, how much does she have left? How much does she have left? Now, you better make sure you remember what you read. This means that what we're going to do is figure how much she spends on paycheck for the rent and how much she spends on food and subtract that then. So you don't just automatically take the numbers that you get after you multiply and write that answer down. So what we must do then is this. We're going to spend 1/3 of the paycheck on rent. So that 3 will go into that 100, and so we have $100 out. We're now going to spend 1/4 on food, so it's 1/4 of, so it's times, and that will divide into this 75. Now we need to decide, all right, that's how much we're going to spend in all on those two items, so that's $175. That is not the answer. Don't go over here and mark this answer yet. Read the problem again. How much does she have left? Well, that means then she must take the $300 and subtract the $175 and get the correct answer of $125. So learn to read the problem 2 or 3 times. Act like you're that particular person, and what would you do with the numbers? Add, subtract, multiply, or divide. All right, now let's look at the next example. Okay, it says Betty drives 425 miles to Tulsa at a rate of 50 miles per hour. How many minutes away from Tulsa is she after 8 hours? Ooh, wait a minute. She drives 425 miles to Tulsa at a rate of 50 miles per hour. Okay, it's miles an hour. And then the question says, how many minutes? How many minutes? Changes on us. So we've got to pay attention. Our answer must be in minutes, not hours. All right, continue reading. It says, how many minutes away from Tulsa is she after 8 hours? Now, well, it says here that she drives 50 miles per hour for 8 hours. So that's 50 miles per hour for 8 hours. So that's 400 what? Miles. But she's supposed to drive 425 miles. So she still has 25 miles to go. Well, she's driving at 50 miles per hour, so that says she has 1/2 of an hour left to go. Now you've got to watch exams and teachers and questions that you get on exams, and the answers over here, they might put a 1/2 in there and the 30 also. Whereas it asks in minutes, therefore the answer is 30 minutes and not the 1/2 hour. So pay attention to words and everything, and don't just slap down answers. You get an answer of 1/2 hour, but you've got to realize that's the same thing as 30 minutes and then answer the question. All right, let's look at the next example. Okay, next example says if 4 packages of spaghetti cost $2.10, how much will 6 packages cost at the same rate? And that's package cost, package cost. So hey, we might use that as a ratio proportion. We could say 4 packages is to $2.10 as 6 packages is to X dollars. Cross multiplying and solving that, we get X to be $3.15. So here's where you could use ratio proportion. Well, we probably don't do that. If we go into a grocery store and find out that a 4-pack of something is $2.10, probably what we'll do is come along and say $2.10 divided by 4 and figure out that's $5.25. So we're saying that's 52.5 cents per item in that 4-pack. And then we'd multiply that by 6 to get the cost of 6 of them. And we'd get the same answer, $3.15. Or another way of doing it, this is probably what I would do. If 4-pack is $2.10, then half of that pack would be 2. So if I add that to the 4, I'd get 6. So really just a half of one of these other 4-packs would be then $1.05. And if you come along and add $1.05 to $2.10, you also get $3.15. So just the reasoning process, what we're saying is if you want to write it as a ratio proportion, we have taught you how to handle that. If you want to do it as just a reasoning, like $2.10 for 4 divided by 4 gives you how much each one is, and then multiply by 6. What we're trying to teach you is how to do that division, do those decimals, and so on and so forth. All right, let's now look at another example. Okay, by working at a store, Bob gets a 15% discount. A bicycle that he wants usually sells for $80, but it is on sale in the store at 35% off. Now, how much will Bob have to pay for the bicycle after both the 35% reduction and the 15% discount? Well, now, does that mean we can just add the 15% and the 35% together and then take that percentage off of the cost? No. That's usually not the way you're going to do it. What you'd probably do, you'd go up to the counter and say, well, I'm supposed to have $80 item here, and I get 35% off of that. Now remember, 35%, you move the decimal 2 places, take away the percent sign, and now we multiply. And when we multiply that, we get $28. So that's how much we get to subtract. So we're going to get to take the $80, subtract the 28, and now we have left $52. That is what the item would cost anybody that came in and got their 35% off of that. But now we as the employee get a 15% of that discount. So we would now take the $52 and multiply by 0.15. 0.15, okay? That's 15%, move the decimal place 2 places. And that will come out to be $7.80. So that's how much money we get to take away from the $52. So our cost then is $44.20. So our answer is D, $44.20. Now, on the task test, and a lot of these examples, you have to be careful and watch out for them. What they usually do is give you answers that if you foul up one process here, they'll give you the answer that look like it'll be right. In other words, if we'd taken the 35% and added the 15% and then worked that of $80, we would have come out with one of these answers. Another thing to pay attention is reason. Estimation, reason. Surely you know that you wouldn't be getting the bicycle for $4. Okay, learn to have some reasoning process of what your answers should be. All right, let's look at the next example. Next example says, at the beginning of March, the Johnson's water tank was 3/4 full. At the end of the month, it was 1/8 full. If the tank's capacity is 200 gallons, how much water do the Johnsons use in March? Well, wait a minute. Let's read it again. It says at the beginning of March, the tank was 3/4 full. And let's see, go down 2 more lines. It says the tank could hold 200 gallons. So that means at the beginning of March, we would have 200 gallons times 3/4 to find out, before going to that, 50. So that means then at the beginning of March, we had 150 gallons in the tank. Then it says at the end of the month, it was 1/8 full. So we start back over and say, well, 1/8 of 200. Okay, dividing that into that, we'll go 25. So that's 25. So this means at the beginning of March, we had 150 gallons in it. At the end of March, we had 25 gallons in it. Now, what do we do with those two numbers? And again, if you notice the answers over here, they have all different, these numbers. They have all the numbers that we could think of. If we added these, we'd have A. If we just took the top one, we'd have B, and so on. So what do? We had this much at the beginning, we had this much at the end, so if you subtract those, you get the correct answer of 125 gallons. But just read the problem and think what you would do if you were there working the problem. All right, next example. The next example says Mr. Diaz bought 10 boxes of alarm clocks, boxes now, not clocks. He bought 10 boxes of alarm clocks for each of his 3 stores. Well, that means what? He bought 10 boxes for 3 stores, so he bought 30 boxes. Then it says if there are 12 alarm clocks in each box, how many did he buy? How many clocks did he buy in all? So then it would take the 30 boxes times how much in each box, and we would get 360 clocks. Okay, 360 clocks. Okay, let's look at another example. All right, next one says a 12.5 liter punch bowl is filled with 3.5 liters of orange juice, 1.5 liters of pineapple, 7.5 liters of ginger ale. Approximately what percent of the punch is made orange and pineapple juice? Wait a minute now, percent. Percent is part over the whole, okay? The part over the total. Well, we have 12.5 liters in all, and we want to know what the percent of the punch is made of orange and pineapple. So what was there? 3.5 orange and 1.5 pineapple. So if we add the orange liters and the pineapple liters, we get 5. So we put 5 over the total. Divide that out and you get 0.40. Now the question is, what percent? So this is not the final answer. To change a decimal to a percentage, you move the decimal 2 places, and so our answer is 40%. So we come down here, and that's our answer. Percent, from the tape, you're supposed to know, is the part that you want, the part that you're talking about, over the total. Divide that out by division. Move the decimal place 2 places, change it to percent, and there you have the answer. All right, let's look at the next example. Okay, it says on a map, 2 centimeters represents 50 kilometers or kilometers. Now, kilometers or kilometers is 1,000 meters. If 2 cities are 10 centimeters apart on the map, what is the actual distance between the 2 cities? Now this is the thing where it says 2 centimeters represents 50 kilometers. 2 cities 10 centimeters apart, what's the distance between the 2 cities? Keep reading that, but it looks like that's a ratio proportion. What that says is for every 2 centimeters, okay, on the map it represents 50 kilometers on the ground. So I will come over here and say then what is 10 centimeters to the distance on the ground? Now see, we got a lot of numbers in here. We got the number 2 and the 2 and the 2 and the 50 and the 10. What we've got to do is realize that this says that 2 centimeters represent 50 kilometers out on the ground. And then in this 2 cities, just talking about the type of situation we have, the distance between 2 cities is 10 centimeters on the paper. What is it out on the ground? So cross multiplying, we get 2x is equal to 500. So dividing both sides by 2, we get x is equal to 250 kilometers. All right? So our correct answer then is D. Wait a minute, we could have done another reasoning process. Let's go back and look at this. If 2 centimeters represents 50 kilometers, then that means 1 centimeter represents 25 kilometers. So, what does 10 centimeters represent? 10 times that, 250. There's not just one way to work the problem. If you reason it and then just simply know how, if you like to do it by ratio proportion, that's how you do ratio proportion. If you like to do it by reasoning, this is what you have to do by reasoning. All right, let's look at the last example now. Okay. The last example says a supermarket has 36 crates of apples, 7 crates of bananas, 18 crates of oranges, and 11 crates of grape juice. What is the ratio of crates of apples to crates of oranges? Well, that's simple. Just ratio. That simply says go put one number over the other number. All right. What is the ratio of crates of apples? Well, crates of apples, 36. Take 2 crates of oranges. Crates of oranges are 18. And so dividing 18 of that 1, 18 of that 2, so the ratio is 2 to 1. Okay. So the ratio is 2 to 1. You don't call that 2 or just the number 2. You say the ratio is 2 to 1. What that's saying is for every orange, there are 2 apples. So the ratio is 2 to 1. Now, what you need to do now is to work a lot of the examples and the problems at the end of these notes. There's not a lot of lecture here and not a tremendous number of examples, but enough to get you started in just taking a practice and drill. So be sure now that you work the problems following these examples. We can do this. 4 will go into this. 25. So now, what do we do with those numbers? We add them. So the answer is C. No, wait a minute. Read what the problem says and you think what it's talking about. It says at the beginning of the month, the tank was 3/4 full. So the capacity is 200. At the beginning, that meant we had 150 gallons. That's what this 3/4 of 200 is giving us. So at the beginning of the month, we have 150 gallons in there. And it says at the end of the month, it was 1/8. So at the end of the month, there were just 25 gallons in there. Now, how much did we use? Well, so you do what? You simply subtract them. So subtracting these, we get 125, and so the correct answer is C. Again, don't just write down numbers and without knowing whether you're going to add, subtract, or divide by reasoning. Okay, now, what they'll do to you on test is give you answers that will, if you do the wrong operation with these numbers, they'll have them there. So you make sure you read the problem carefully and think what you're doing if it's in real life and you were responsible for coming up with these answers. All right, let's look at the next example. It says, Mr. Diaz bought 10 boxes of alarm clocks for each of his 3 stores. If there are 12 alarm clocks in each box, how many clocks did he buy? Now, think about that. If you got 10 boxes of alarm clocks, and in each box there are 12 in there, then what do we have? Okay. Well, if we have one box, we have 12 clocks. So if we have 10 boxes, then that would be 10 times 12, or 120 clocks. But wait a minute, he said he did this for each of his 3 stores, so we want to come back and multiply that by 3. Now, there are a lot of ways of getting to this problem. For instance, we could say, well, look, he bought 10 boxes for 3 stores, so he bought 30 boxes. And how many is in each box? 30 boxes times this, and we'll still get 360. And so the correct response is D. Okay, again, realizing that what I'm trying to say to you when you work these kind of problems is read the problem carefully several times to get in your mind whether you're going to add, subtract, multiply, or divide. What we're trying to teach you with our set of tapes and in class room situations is the mechanical work of how you multiply, add, subtract, and divide decimals or fractions, or how you work with percents. All right, let's conclude this tape now and work some of the example problems and take a break or so, and then look at tape 6B for the continuation of the set of notes.